Hello, my name is Alastair Graham. I am part of the Oxidian team delivering integration components for the EOData Hub. In this video, I would like to give an overview of the work done to date around integrating various components into the Hub. Please be aware that this is being recorded mid-September 2024, which is pre-release for the Hub itself and for many of the application and integration components. Therefore, much of what you see may change in the future. However, we hope that this gives a good overview of the direction of travel for the Hub and for the ways of integrating with it. The Hub itself has a dedicated training site. You can get to that at eo-datahub.github.io/EODH-training. If you need to get to any of the source code at any time, click this GitHub button on the top right hand side. At a later date, we will also have a community discussion board where users will be able to ask questions and get help from each other. The main content on this site at the moment relates to 3 notebooks that were presented to DEFRA in September 2024. I will go through those now. First off, we want to understand how we can find data on the Hub. To do this, we're going to be using a Python API client developed by Oxidian called PyEODH. If you know PyStack, then PyEODH will be very familiar to you. After we get through the information at the top, we get into the code itself. For this series of notebooks, we're going to be looking at 2 areas, a site near Rutland and another site near Thetford. The first thing to do is to connect to the catalogue, and that's what we do here. This connects to the Hub itself and to the stack catalogue held on it. After that, we can start to get information about the collections that are held in that stack catalogue. For instance, we can see that there's climate data such as CMIP6 and Cordex, and Earth observation data such as SAR data from Airbus or the Sentinel-2 ARD dataset that CEDA provide. There are ways to find out individual items and also information such as the temporal extent of the full dataset itself. Once we do that, we can start to look at ways of filtering even further. So for instance, what I've done here is a search on the Sentinel-2 ARD dataset using the Rutland data point for a specific start date, end date, and looking for cloud coverages of less than 50%. I also limit the output to 10 records. What we see from this is that actually there's only 2 items found. However, the collection will be built out more in late 2024, so the number of items found in future would be much greater. Once we have done that, we can start to understand a little bit more about how Stack is structured, and we can see here that there are different types of products. The data itself stored under COG, which is Cloud Optimized GeoTIFF, access to metadata, and a thumbnail. If we go to the Hub itself, we can see that this is the information that we're looking for, the image that we're looking for. We can see that we have the same information here as well, the data itself, metadata, etc., as well as metadata down the side. Now that we know what we are trying to get to, we can pull out the thumbnail and display it. So this shows that we have the information that we want. Going back to the Hub, if we go to thumbnail and open, we can see it's the same one. So we are looking at the data we want to see. If we want to see commercial data, effectively the same process is run through. We have a look for some commercial information. Here we can see that there's some Airbus data and some Planet data. We find out specifically what the temporal extents are, what the names of the items are, in this case for the Planet dataset. We find out the number of items in each of the collections. So for Planet, we have 1 image over that site, and for Airbus, we've found 2. And then again, we can use the links through to those data in order to do some processing. Once the Hub is up and running, users will be able to find commercial data in this way and then go through an ordering process in order to buy the relevant data and ingest it into the Hub. I'm just going to jump out to QGIS to show you what the different types of data looks like. So this is the Thetford site, and here we can see some Planet data at 3 meter resolution I can then overlay some spot imagery on that. Just let it load up. And if we zoom in again, we can see increased resolution. This is 1.5 meter resolution imagery. And then finally, Pleiades imagery over the top of that again. And this is very high resolution imagery. So these are the types of products that you'll be able to access and purchase through the hub from Planet and from Airbus. The second workbook takes us through data processing using something called the workflow runner. So workflows are set up using a new OGC standard called EO application packages, which are complex constructions of code and data. And at their core is the concept of a common workflow language workflow file. The workflow runner takes all of the information around an EO application package and then scales it horizontally across the EO data hub. In order to use the runner, a user needs to log in. What we do here is again connect to the hub, this time using a username and the API token. Once we've done that, we can see the processes that are available. So in my user space, there are currently 3. If we want to deploy another workflow, we can do that from a CWL file held online. Once that's done, you can see that it's been added into the list. We can also remove it in a similar way using the .delete function. So the next thing that we want to do is be able to do something meaningful. So for instance, we might want to resize all of the images in a collection. For this example, what we've done is deployed a CWL file called resize col CWL, and this takes every image in the Sentinel-2 ARD collection and then resizes it to 5% of what it was before using GDAL translate. So the process is that the workflow runner spins up some infrastructure specific to this task, scales it automatically, and then returns the results to you as a stack catalog. Here we can see some screenshots of a QGIS plugin that has been developed by Oxidian in order to help users find, parameterize, and run these workflow files. I'm going to just jump over to QGIS now and open up the plugin. And what you can see is that we have these 3 workflows available to us, including resize col. I've already run it, so I won't go through that again. But the successful process that was run, you can click on details and it comes up with information about the run itself, but also with a series of output files. And if you double click on one of these, it will open that output file, or you can add them all. You can see that here is the original Sentinel-2 ARD image, and we can overlay the resampled image over the top. If we just zoom out a little bit, you can see that the image is resampled at the full extent of the image. So jumping back into the notebook, when we run the job itself, we get some information out that helps us understand how the job is progressing. And then, as I've already shown in QGIS, we can access the data as a stack catalog. In this final notebook, we're going to look at a couple of examples of how we might want to continue data analysis once we've found some data and run it through a workflow. In this first instance, we're going to use something called local tile server just to understand a bit more about the data. So first thing you can do is validate that it's a true cog, which is successful, so that's good. And then we can also call the URL to the cog file itself that sits on the hub and display different bands just to see what sort of information there is in there. Similarly, we can also look at information that sits in a user's workspace and do the same thing. So if you've clipped some data, or if you have some data that you're bringing to the hub and uploading into your user workspace, you'll be able to use this sort of method in order to view it within the notebook environment. Another thing that we're trying to do is understand how we can create data cubes. We've started to make some progress towards this, and there's some code here that shows how we can do that. Again, it finds some information, it plots it again for one of the sites that we've been looking at, and then runs through the process. So that ends this quick introduction to where we are at the moment, September 2024, in terms of integrating different components with the hub. Finally, we're also close to issuing the first release of a piece of software that helps generate EO application packages. If you want to know more about the Earth Observation Data Hub, then please get in touch using the contact details on the website.